Okay, so welcome back. True or false? Actually, this segment is where most of the people get their mistakes from. So let's focus in this segment a little more. If the answer is true, we'll just skip over it, and if it's false, we will list the reason why it is not true. So, mass is a vector quantity. Obviously, false. What does vector value mean or quantity mean? Basically, a vector quantity is a quantity in which it has a direction. So if we say 20 kilograms, that does not have direction. You can't just say I'm going 30 kilograms. That doesn't tell you anything, which is the opposite of velocity, for example. It's not like when you say, well, I'm heading 30 kilometers per hour west. So this is velocity. This is a vector quantity in which it has a direction. So vector is mass is not a vector quantity. It is a scalar quantity. Okay, so two non-zero vectors. We've got vector v and vector w are parallel if only and also, if and only if vector v and vector w, if you multiply them through the dot rule, gives you 0. So this is false. Why? First of all, the two non-zero vectors, that's good. This part is okay. But what's not okay is this part. They shall be orthogonal. Orthogonal. Apologies for the spelling. Yes, they should be orthogonal and not parallel in order to solve this question. Okay? Or in order for this statement to be true. Moving on to question number 13. The quantity v dot u is a scalar, which is true. Why? Because if we've got the dot rule, if we use the dot rule, okay, if we use the dot rule, then the quantity or the product we'll be getting is scalar, okay? While if you use the cross rule, then the quantity we'll be getting is a vector. To test this out, if you get with the dot rule, you're gonna get a magnitude. Okay, you're getting a magnitude in which it's like a number 30. That's not vector. That's not a direction. You cannot tell anything about it. It's just a magnitude. While in the cross rule, we've got I and j and k all being vectors, meaning that this value will be a vector. It has a direction. So question number 13 is true. Question number 14, the plane x3, -3 has a normal vector. And again, every single time we say normal vector, we always watch and pay close attention to the coefficients. So here we've got x is 1 and y is 3 and z is -3, which is also true here. You've got 1, 3 and -3, so that's true. Also, for this question, I think the third question it was, where is it? The third question, yes. So here we have to write it in this format. So we've got 1 here, and then we have to write I vector, and then -1 j vector, and +2k vector. I wrote it in a weird format. I wrote it as 1, -1, and 2k, which I'm not sure if it's correct or not, but sticking to this format is better. Okay, so continuing the question, or true or false questions. V cross U is a scalar. Obviously, we just mentioned that that's false because we just said that using the cross rule, then we'll be getting a vector value and not a scalar value, meaning that this question is false. So, fill in the blanks with the correct answer from the word bank. Unfortunately, we don't have the things to fill or the statements to fill. Hence, we'll just write the definition of each one of these key terms. And in the exam, hopefully, we get to know how to fill each key term in their places. So, a transpose of a matrix. Each matrix has a transpose version of itself. What does a transpose of a matrix mean? Basically, making, and I'll write each one, making rows into columns and making columns into rows. So this is the transpose of a matrix. Multiplication, in order for a multiplication between two matrices to, well, happen, they have to be conformable. And how do they be conformable? Number number of columns in first matrix shall equal number of rows in second matrix. What does this mean? Okay, we've got here matrix A, we've got matrix B, okay? And let's say that the rows in matrix A is 17, sure, and the columns are 2, while in the B, it's the rows are 2 and the columns are 27. Can you multiply these two matrices? Yes, you can, because here, number of columns equal number of rows. If these two numbers beside each other equal each other, so 2 equal 2, if they are equal, then yes, you can multiply them. But if they are not equal, so let's say one of them is 3, and even if this is 17, so this is 17, 17, this does not work. These two numbers beside each other shall equal each other for it to be conformable. So this is multiplication between two matrices. Velocity vector is basically telling us ratio between displacement over time. Unit vector, magnitude equals 1. Mag equals 1. And what is magnitude? Here it is. We can define it right away. Magnitude of a vector is its length. And we already solved 2 questions of those where they asked us, not 2 questions, but this question. Oh, actually, never mind. This is not the question I had to answer. Yeah, this is the question with the normal vector, where I had to write it like this. Minus 1j vector and plus 2z vector. Anyways, that doesn't matter. But yeah, this is the length of vector where we got square root and the coefficient, and we squared them and we got their sum. So yes, this is the magnitude, which is the length of a vector. Displacement vector. From the name, you can tell that displacement is basically the difference in distance, which is final, basically saying final minus initial. So the shortest distance between the final point and the initial point. Finally, the vector components are basically the axis. You've got the x-axis, you've got the y-axis, and you've got the z-axis, like that. Let's see. Let me solve. Yeah, sure. I'll solve these 2 questions. Decide whether the vector v is parallel to each of the following vectors. How do we tell if a vector is parallel to another? Basically, there must be a constant ratio between all of its components. So this is component I, component j, and component k. Let's see if vector v is parallel to vector w. Now, how do we tell? Let's see how many i's does v has. V has 2 i's, okay? While w has 4. So we see that we multiplied v by 2, okay? So the I in v, we multiplied it by 2. For j, we see that v has 3j, while w has 6j's. Again, we did multiply j by 2 in the v. This is talk about v. And finally, v has 5k's, while w has 10k's. So yes, again, we multiplied k by 2, meaning that we have a constant ratio, which is 2. So, therefore, and we have to write it in this format, therefore, vector v is parallel, that's not parallel, is parallel to vector w. Why? Because 2v, as we saw, if you have 2 of v, or you multiply 2 by each component, then you'll be getting the vector w. So this is for question 1a. Disregard this being a. Okay, so let's do it again. with question number 1b. So this is A, this is B, and this is C. So question 1b, we see that what happened between 2 and -1. So 2 to -1, what happened? The order of operation we did was we divided by -2, right? Okay, so let's see if this ratio is constant between all of the components. So we divided 2 by -2, which we got -1, so that's true. And then we divided the 3j by -2, and we got -1.5, which is also true. And we divided 5 by -2, which shall give us 2.5 k, and which is negative, and that's also true, meaning that we divided all of these components by -2, and we got vector A. So again, we will say therefore vector V is parallel to vector A. Why? Because let's say -2A equaled vector V. So both of these are vectors. Moving on to question 1c. So let's see what happened here. Again, let's remove these scribbles and start solving the question. So in the eyes here, V has 2 eyes, while B has 4 eyes, I mean. So we multiply the I by 2. Let's see if this ratio continues. With the J component, we see that V has 3 J's, while B has 6 J's. So again, we did multiply by 2. So hopefully this ratio continues. But in this case, we see that we have 5 K's in V, but we have only 9 in B. But if we multiply this by 2, then we'll get 10K. And this is 9. So there isn't a constant ratio, meaning that, therefore, once again, vector V is not parallel to vector B. Why? Because, well, there is no constant ratio. So this is how we solve question 1a. Keep in mind this whole method because we'll use it in the next question. Find the values of A, so of A, making these two vectors parallel. Now again, if basically this question they're telling us what's the value of A. Okay, so there's a value of A in which if we sub it in these two vectors, then it will make vector V parallel to vector W. Okay, so what's this point, or what's the magnitude, what's the value of A? This is what we're looking for. And we can create a ratio. Basically, if we say -3/6, so -3/6. So this is the ratio between vector V and vector W in which they will give us a parallel, it will make the two vectors parallel, okay? So if we take this ratio, -3 and 6, again, if we took the -3 from the left side, so let's take it again from the left side and the numerator. So 5a over the denominator will be a squared. We can just simply cross multiply. So 6 times 5a will give us 30a, and this will equal -3a squared. Yeah, we can just divide by -3. So we get 10a will equal, or -10a will equal a squared. And we have here, a squared is basically saying a times a. So if we just remove 1a with this 1a, it will leave us with -10 will equal a. So basically we're saying that in the point where a is equal to 10, both v and w will be parallel to each other. But in any other point, they won't, unless you take any value that's the multiple of 10. That being said, I believe we are done for this video, leaving us with just 1, 2, and only 3 questions left. Thank you.